And before we get deeper, actually I have integrated with the Langsmith. So Langsmith is platform that actually you can see how LLM being called. So in a previous video, we've run some LLMs that using task one. So here we will show like the model we use, the cost we get, the tokens we use, and the input and outputs. And of course, for different kinds of demos, we will record the input, the output, and some metadata attributes here. And maybe I can show more details like in a task 2 demo. For now, let's dive into the task 2, the uh, generalized browser automation agent. So the requirements that we want to do here is for an agent that can accept like natural language reliably, executes across different sites and demonstrate substantive self-correction and self-maintenance. So it also heavily emphasizes preventing like silent failures. So let's look at the UI. Because browser tests can take several time or several minutes, many steps maybe. So I implemented a server-side events streaming architecture (SSE). So you won't just see a loading spinner, you will see the agent's exact thought process, step-by-step milestone and confidence scores and like hero activations and render live on the screen. Maybe we can start from a normal extraction mission. So if we want to maybe like extract some data, okay, so maybe I want to go to the go to these websites and go to maybe like we can change here these websites and report the paper title plus first two authors, and let's execute it. So yeah, so this is as it runs. Yeah, let me explain it. So this isn't just a basic agent that blindly follows the pre-generated script. It operates on a like four-stage loop. So planner, executor, observer, and healer. After every single action, it observes the new page state and dynamically designs the next step. This is called like reactive planning. So to achieve like self-maintenance against UI changes, I discarded like fragile CSS selectors. Instead, the agent uses the AOM locator strategy. So it reaches the accessibility tree of the page, which is 10 times more like resilient to UI redesigns than raw HTML. So if a class name changes tomorrow, the agent doesn't break because the semantic role still remains the same. Okay, so this one we can get a final insert here. So let's see the Langsmith here. Let me refresh it. We can see it. So we can see like a test 2, we have recorded how many steps, and it actually used 2 steps and to finish all the things. So these are the prompts that I've designed here. So yeah, it's the as you can see that the test completed successfully, but what happens when things go wrong? Um, maybe here nothing will go wrong. You can see other kinds like I want to get some data from other things. What I want to trying to say is like I'm not building the prompt that asks for substantive like self-correction. Okay, well, it's not just a try except block. So if a click fails or a page doesn't load, the agent like trigger a healer. So for example, here we got a healer here. So because we detect the captcha, so this is actually uh, limitations right now. The healer deterministic we'll know the root cause. Maybe it's element hidden or unexpected, like pop-up, catch-up detected, network error. So once it's classified, it will apply target recovery strategy. For example, if it hits a hot maybe a pop-up, it will actually like attempts to dismiss it. So if it hits a red limit, it will back off, and it only escalates to an LM-based diagnose if the deterministic rule fail. so which serves significant, will save the significant time and cost here. Okay, so another things that I could say is like it would be like silent failure guard. For example, maybe I can come out example. Let me think. Uh, so maybe I want to give you this kind of example.com, and I want to let the LLM to say like maybe find a uh, contract email for European trade disputes. And actually, example.com don't have this information, so it's a trap. And let's see what it will happen. So the silent failure guard, the worst thing an AI agent can do, hallucinates success when it actually fails. So I'm going to give it a native task asking for a trademark dispute email on example.com, which does not exist. And generic agent will often like give you a random example to just complete the task. And let's see what happens here. So notice the results maybe at the moment. The agent actually trying to search the DOM and couldn't find it. In the final status, uh, trying to maybe scroll down. So the healer step in, trying to locate. Maybe there are some elements they may oversee. Trying to find. Okay, to extract the email and trying to scroll down. And so actually, this AOM will correctly reproduce not found. So how does it do this? So the silent failure guard runs after the agent thinks it's done. Uses two checks. First, a multilingual hedge-phrase detector that flags the phrases like I cannot found. Second, a strict numeric grounding check. If the LM returns number in its final answer that do not literally exist in the observed page text, it will force override the status to unverified. So this guarantees the agent is honest about its limitation. Okay, and another things are so the same things are actually like linking logging. It will shows a hallucination or some or it is doing the same thing because it can log in. It can't log in, so you will report like something that you cannot find. But finally, there's another option you can see here. Use the vision toggle. So when activated with the supported open water model, tools like Gemini Pro, GPT 5.5 Cloud Opus, the observer attach a bounded like screenshot history into the payload. So this allows AM can literally see what changed visually between steps, and which is incredibly powerful for complex canvas charts or like map 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 layout. Maybe let's try this. Maybe we can see um, what kind of this landmark would be. This of course is an example, but what you can see is like in the middle would be like something like Chem, the Mars, or for Eiffel. So what we can do is like okay, let's go this and trying to see if can actually describe what landmark or area is centered in the map. So let's give it some time. It will of course call the planner, and we are enable the vision part. So it will take some screenshots for AOM and trying to see what's centered in the map and analyze it and trying to give out the results. And if we want to see like actually what's under the hood, we can see like it is still actually running. It will call like different kinds of actions or input different kinds of things. And of course, the tokens that we are used, the image that we are attach. So the LM can actually output with a better answer here. So you can see it output the answer is like the Troy field. So it actually aligns with what we see here. It's correct. Okay. So to sum up, this test tool is like for self-healing AOM-driven agent that prioritize honestly over hallucination, making it highly reliable for real-world automation. Yeah, so maybe the next video I can show more about that text 3 SEC 10K pipeline. Okay, thank you.